Welcome everyone to, it's not 2:04 yet, I lied. There it is, 2:04, okay. Welcome to Friday, welcome to Zymposium. Today we're gonna be going through in a pretty rough around the edges way, sort of just extemporaneously on our toes, showing you how we might, if Adam and I were dropped into some foreign code base, how we might convert it to ZIO from Akka. Obviously, still the topic of the day, converting things from ZIO to Akka. Though, hopefully, this will also be sort of just a general review of sort of building idiomatic ZIO apps, because we'll be doing some refactoring along the way. Though this application that we're going to be using is quite simple. So let me actually share my screen and post some links. So we're going to be porting this application called Akka HTTP microservice by the Iterators, which seems to be a consultancy company based in Warsaw, Poland. But yes, we just basically searched the web, scoured it for example Akka apps that we did not ourselves write, and then picked this one because it's relatively tractable. It's pretty small. It's basically just 1 mega file. Not even too much of a mega file. It's just a few hundred lines of code, yet it uses Akka HTTP, a bit of Akka streams, and it uses config and JSON serialization. Just a good candidate for doing something in the next 55 minutes, where we can show a real change. So the goal would be to basically move that over to not using Akka anymore, and sort of potentially incrementally as well. We sort of in our Akka panel last week, and the video I think is still forthcoming there. But one of the questions that we received was just basically how might you tactically move a large code base from Akka to ZIO, and like, should you stop the world or should you do it incrementally? And obviously you just really can't stop the world. Generally at most companies, they don't let you stop the world, or they don't have the power to stop the world. So incrementally is sort of the answer there. And we can look at some tactics for doing that. And in my opinion, ZIO provides some nice capabilities for migrating. I've migrated a few applications in the past, and it's been relatively simple. Actually, not from Akka, but from Play or other non-ZIO frameworks. Either T's and futures over to ZIO. But this one's relatively simple, so let's just dive into the code. And if you have any questions, definitely throw them in this meetup room. And let me copy that link, because apparently the old link I had has expired, and I'll throw it in the chat. So now that should be in the Scala chat. So come and join us there. Oh, and a couple of questions.
Awesome. Wow.
Nice. Maybe we could, let me just get to this now since I have it. ZIO HTTP currently lacking in features compared to HTTP4S. In the sentence, to peer open API integration is difficult. I could only use redoc to generate Swagger documentation that gave an ugly and useless web page, unless the endpoints could not be tried out. So yeah, currently ZIO HTTP itself does not support open API, but to peer would, which would integrate with ZIO HTTP. And apparently I haven't used it myself. So apparently you've had a bad experience with that. So that's definitely something to look out for. Currently, and in fact, that's something we're gonna talk about later, is that we're planning on introducing a DSL not too dissimilar from to peers, that is sort of hard coded to ZIO HTTP. That should give us some really interesting performance benefits that we've been exploring. We have some PRs in the current branch. Actually, they've been merged into the current ZIO hosted branch of ZIO HTTP, but it's still a little new. So we're not going to look at that today, but I'm sure in the near future, we're going to explore that. And obviously we do want to have open API support. So definitely want to make it good. So yeah, I mean, if you could elaborate a little bit, maybe in the Discord chat or anywhere really, about sort of the output you are looking for, or even if you wanted to open an issue in ZIO HTTP, we definitely want to support that use case. And we're sort of all hands on deck with making ZIO HTTP as pretty as it can be. So yeah, these sort of any features that aren't currently there for you, let us know what those are, because we would love to make them really shiny and nice. Last time I checked, I did not find support for creating ZIO to peer ZIO HTTP WebSockets endpoint routes. At least I did not find examples for how to do that. I'm not sure if to peer supports WebSockets. I've never tried it. It probably does, but maybe it doesn't. I just don't know. But as I mentioned, we're sort of trying to put everything into ZIO HTTP itself, just for, I mean, it's just the experience that I would want as a developer, to just not have to introduce a ton of libraries, and to have the libraries I do use sort of be built for sort of be opinionated, and to I think one of the trade-offs with Tapir is it's an amazing library. It's really well written. It's really robust. However, it needs to sort of work against so many different backend servers. It cannot specialize, which means it loses out on performance opportunities as well as just ergonomics opportunities. For instance, it doesn't, I don't believe that the ZIO endpoints take advantage of covariance or contravariance of the error or environment types respectively. So you have to do some manual widening. And in ZIO code bases, generally you don't like to call the .widen or .narrow method, because we like to use the type inference that you get from variance annotations. So that would be something that we would be looking at. But also we have ZIO HTTP, sorry, has WebSocket support, but I don't know if there's I think we're still working on the API for that. So that is something that's definitely coming down the line. And if you need that right away, I think, you know, frankly speaking, like currently at this day, you'd have to either deal with some churn there as we polish up those endpoints, or use something else while we figure that out. But definitely register these as either issues. The more we hear about them, like the more we're going to prioritize these use cases. And also, I'm sorry, no one can see these questions, or this question as I'm reading it, because it's a part of the Zoom HUD. I think at least, hopefully it's floating somewhere magically, but I'm not sure if it is. So the second part of this question, or maybe the third part, is I know HTTP4S is a difficult way to widen the server endpoints. Took me a while to figure that I have to widen the endpoint. Yes, exactly. Will ZIO HTTP have better support for Tapir in general? Okay. So yes, I think I accidentally preemptively responded to this, which is that yes, I know, I don't think anyone likes widening endpoints, and the error messages can be very unclear if you don't know that that's even what's causing these weird type errors, because generally, if you're widening tons of things, you're going to see all these type parameters. It's not going to be clear unless you already know what you should be doing, and you already know to widen it. So it's kind of like a worst case scenario. The error is inscrutable if you don't know it's not a helpful error message, basically. And you have to basically talk to an HTTP4S or Tapir guru to know that, oh no, you have to just call the widen keyword, the widen method. So yeah, ZIO HTTP, the API DSL we're working on, will not require widening, because we're going to have it be a covariance and contravariance in the environment and error types. So it should just sort of work like everything else does in ZIO, where you generally do not have to provide type descriptions unless it's a particularly tricky situation. So yeah, thanks for the question, and yeah, thanks you for the follow-up. Thanking us for the answers. Thank you for that. And if you thank me for this follow-up to that follow-up,
it will be an infinite recursion of thank yous.
But no, seriously, thank you very much. Cool. Well, great questions. I'm not sharing. Wait, am I sharing now?
No,
I think I'm sharing an empty desktop. Yes, I am sharing an empty desktop.
Now we're saying, yeah.
Yes. No, I was reading the question, and unfortunately, I should have copy pasted it or something. But I hope that was helpful. Now trying to find IntelliJ. And we'll look at real code. Okay, good. Real code. Yes. So basically what I've done is I've pulled down the code base and I've added Scala format for my own obsessive compulsive requirements. So it's slightly formatted, hence the blue over there. And I've also, the only thing I've done is added to the build SVT file some ZIO dependencies that we may or may not be using all of, but previously it wasn't using ZIO. So I've added ZIO JSON, ZIO HTTP, and STTP for the ZIO backend for that. And yeah, we might not be using all these today, but just to get them in there in case we do want them. A bit of a heads up, we haven't met our, though ZIO HTTP has been moved over to the ZIO organization, we haven't made an official first release yet. Sort of we want to make some changes and add some of those features like that API DSL before we do that. And so we're using the one that was the final release made by Dream11, who created ZIO HTTP and made it pretty dang awesome to start with. So we're going to be using that DSL, the existing style DSL. And we'll talk about some improvements that can be made. But yeah, it should nonetheless, this should be enough to get started moving some stuff over. Cool. So, oh, and the one last thing I did was moved back to a previous version that was using Scala 2, because they did upgrade to Scala 3, and they didn't really make too many changes with that except to change one either to a union type. But besides that, it was basically identical. And I, as most of you know, I'm obsessed with IntelliJ. and I was getting some weird errors. So unfortunately, I just rolled back. It was mostly just version updates and that one either to union. So with that being said, that's where we're starting. Nothing up our sleeves besides that. Dependencies, formatting, went back a few commits to Scala 2. And other than that, it's basically the same exact application. And I'm guessing if you have an existing Akka application, chances are it's still on Scala 2, if I had to just guess. Most production Akka applications are likely on Scala 2 and not Scala 3, but maybe some of them are. Great, so let's just talk about the structure of this application. First of all, what does it even do? So maybe one way to sort of figure out if you are tasked with investigating or porting over an HTTP server would be to start up the routes being sort of the interface of this application. So, well, we can see that here are the routes, and there's this path prefix IP. So it looks like there's a couple routes that start with /IP for, well, IP address, not intellectual property. This is doing something with IP addresses. And then it looks like this is a handler for a GET request, and it's going to accept some kind of, it's going to parse a path segment out of the URL. So there's going to be some kind of path segment here that's going to be parsed as a string. In fact, it's going to be parsed as some IP address. So we're just going to parse whatever second segment is there as an IP address, or as a string rather, a string that represents an IP address. And that is going to be a GET request. So it'll look something like this: a GET request at /IP/some IP address. Then there's also a post underneath the /IP header. So the path prefix is wrapping all of this. So we have a GET handler with a /segment and a post handler that itself requires this entity. So what this is going to do, it's not going to try to parse out some crazy entity in the route. Rather, it's going to expect there to be a post body, and it happens to be trying to parse this data type, which is simply just a pair of 2 IP addresses using a JSON decoder that's currently sort of stored. They're using this trait pattern where all of the codecs, all the decoders and encoders for these types are being derived and put into a trait and then mixed in later on where they're needed. And we might change some of this stuff around to match our preferences a little more, but for now, this is fine. And we're going to try to sort of do this incrementally and not change everything all at first. So step one, let's understand what's happening. So yes, there's going to be a post with a body being some kind of, what is it called? IP pair summary request. So really there's two endpoints. One is calling this fetch IP information method with a single IP. This other endpoint basically does the same exact thing except with a pair of IP addresses, and calls it twice, once with each of those IP addresses, and then returns basically a tuple, a named tuple essentially, a pair of those results versus just a single result. So it's just like really an arity of 1 and 2 handler there. So we get info.
This one's kind of doing later on the fancy stuff about calculating distance between these 2 IP addresses, right?
I actually am not even sure if it's doing that. I know the README mentioned something about getting the distance, but I think it just actually gets. So yeah, let's read this real quick and let's make it way bigger. Maybe I should read the docs before just going out. So the service in this template provides 2 REST endpoints, one which gives geo-IP info for the given IP, and another for calculating geographical distance between a given pair of IP addresses. So that's what it says, but looking at it, it doesn't seem to actually be, unless, oh, never mind. Tricky, it is. So the apply method, I was tricked because it's a case class, but there's an overridden apply method that also calculates the distance between them. Okay.
That is
so
so actually that's a huge anti-pattern. So yeah, you have a apply method of a case class that is not just doing something mutable, but yeah, is, I think, calling that's not so good. Yeah.
Oh, well, I don't think it's. I don't think it's actually.
Oh, it's already gotten it, so it's just doing the calculation.
Yeah.
But yeah.
So it's not quite an anti-pattern, but what maybe in this case, just due to the fact that we're so used to, basically the apply method just creating a case class and putting the values in there. It might be nice to name this instead something like, calculate, or from IPs or something.
Yeah.
Or IP pair with distance. I might want to somehow reflect that, but for now we'll keep it as it is. But yeah, because of the naming, I just assumed that it was just bundling up those two IP addresses in a name tuple. But no, in fact, it's also calculating the distance between them. Another thing that's occurring here is there are some non-Unicode characters. We won't even worry about that because I'm not actually sure what this means. But not being a math person myself, I just see a delta and then some kind of, is that tau? I don't really know. There's a lambda and a delta, but I don't really know what a tau 1 or tau 2, if that isn't even tau. I don't honestly know which one that one is. It looks like Walt Disney's signature a little bit. But it's doing some kind of distance math, and we're not going to even worry about that implementation. But
yeah, and I think this is like the perfect example of the kind of code that like you don't have to rewrite the whole thing from scratch. Like there's a bunch of like mappy stuff going on here, and we are not even going to touch this. This is going to be exactly the same in our Akka and our ZIO version.
Though I do wish Earth Radius was given some fancy Greek, bar there. But that's nice, Earth Radius. So yeah, it's doing some kind of I don't know, non-Euclidean transformation. I have no idea. There's at least a link here to something. Movable type. This page presents a variety of calculations for latitude, longitude points with formulas and code fragments for implementing them. So this is where they got the fancy Greek from. So great. This uses the Haber sign formula. Ooh, as a crow flies. Oh, it's all fancy. But yes, this is just totally, we can collapse this. We don't care. It's a pure calculation. We're not going to update that right now. Cool. So I think at least we understand it from a high level. We basically want to create a server that has two endpoints that call into eventually this fetch IP info method, which itself, this is doing much of the logic for getting information. So let's look at what IP info is. This is going to, given an IP address, hit some external API that's going to, I don't know what a query means, but it's going to get us the country, the city, the latitude, and longitude. So it gets us this geolocation information derived from an IP address. And currently, it happens to be using some Akka streaming to make a request to this service's IP API host at service's IP API port. So it's a bit of a strange, to me, flow at least, but I'm not really so used to Akka, but it seems a little odd to me that really what we're wanting to do is basically hit some API. What I want to do, if this were HTTP, it would be something like, basic request.get, some URI or something, some host /JSON/IP. And that would kind of be the GET request. But instead, what seems to be happening here is, if I just make this slightly larger, is that first we're creating this request that doesn't have the host, but only the path. And then we're kind of pushing it. We're making a singleton source out of this. So we're kind of making a stream, if you will, and then pushing that through this pipeline, this API connection pipeline that will send that request to this server. So some kind of like server, which is, that JSON, let's imagine goip.com server pipeline, which will actually make the request and then return the response on the other side. So yeah, this is the ZIO way of doing it, and piping it through this transformer, and then just getting the first element.
Yeah.
So, and we've sort of talked about in the past before, when you like a ZIO is kind of, we can think of it as a stream of a single element, or a C stream as being a ZIO that allows you to represent 0 or more responses. So if we just have the stream, a singleton stream, really, like I think it becomes a lot easier to. We don't need all the complexity of streams, and it would be nicer to think about it as just like we're making a GET request here. That's just a single effect. But yeah,
you can see here, this is kind of a stream implementation leak of like, okay, it's great to support streaming, but here, like, we just want to make a request. We just want to get a response. Why do we have to go through all this weirdness versus like just getting a ZIO that has the response, or in this case, getting a feature that has a response? There's this very weird note here of like, I guess doing it this way is actually anti-pattern. There's some other way, but they didn't want to do it that way. So plenty of weirdness here, but probably what you might expect when you're kind of going into a legacy code base and kind of trying to clean things up. So maybe not a bad thing to be saying here.
Yeah, and also no judgments whatsoever to the nice open source library that exists that we're using as an example. It's an open source project that's an example, a starter. It doesn't need to be like the most beautifully factored code anyway.
Yeah, and I think if you look at the comments, they kind of did it, and then someone's like, "Oh, this was now an anti-pat." It's like, okay, well, we already did our library, so we're happy to make a note of it, but we've kind of done this.
But yes, very grateful this was out there.
Yeah, very much so.
Cool. But also, we're not really going to change this right away. Obviously, to fully eliminate Akka, we're going to want to replace this with probably something like, for now, HTTP. But in our first pass, let's just try to do what we might want to recommend in a production in a larger application that had many, many files that used Akka. We don't want to replace everything all at once. So we could keep this around using Akka and sort of, slowly start from one level of our API and push the boundary of Akka up or down as appropriate. And I think maybe arbitrarily we'll just pick, we could start with actually this service and turn this into a ZIO-ified thing and keep Akka HTTP as the server. But for now, let's just start with the server itself and kind of work our way from the top down, if that works. In a larger application, you can kind of work from both ends, move around, but we'll just start with that example. Okay. And I was just handed a coffee. I'm so happy.
Yeah.
Though it's slightly cold. No, it's fine. It's very good. Okay. Where are we? Okay, there's also some config that's using a config factory. So it's using the type safe config thing, which is not fully, type safe and wonderful. And we can eventually move that over to being its own service, and eventually even using, ZIO config or something to read that and make it a little more type safe. But let's just start somewhere. Let's start somewhere. Now that we sort of have gotten an overview of the calculations and types involved in the structure of a relatively simple 130 line application. So looks like the other thing that happened was we were messing around a little bit before and made some folders. So those have remained as well. So I think what I first am going to do, because this is not in a package, I'm just going to drag this over to this IP service package I made, and hopefully nothing explodes. Sometimes IntelliJ gets confused, but usually it's fine. That's nice. And then what I'm going to do is use some things just to clean this up a little bit. I'm going to move all the models into their own a package here called .models for now, just to get them all out of the same folder. And so if you happen to be using IntelliJ, you can hit Command-Shift-A and type in move. There's this move class refactoring, which is quite nice. I've set a shortcut to it to just be Command-Shift-M, and then it brings this up. So I can pick a package even to move it to. So I'll move that over to this other package. That's nice. And so that's created this IP info type here. And maybe I will just, I could do the same thing with everything else. Maybe I will. So I will move that to models because there's only, I think, one last one. And I will move this one to models as well. And this sometimes it screws things up with imports, but then it's pretty smart about suggesting them back again. So I think I want Scala Math to radians. Scala Math POW. It's probably like all of Scala Math. So let me pull all of Scala Math. There we go. Great. So I think everything is happy. And by moving it, it's also, I think, renamed the path in here. So yeah, IP service models. Now we no longer need Scala Math in here. And I'm just going to rebuild. So just a little bit of, code OCD. You can't spell code without OCD. And then a dangling E, which infuriates me to the last of my days. Okay. Let us see. All right, so great. Let's now make a ZIO microservice. So this is the Akka HTTP microservice. Let's make ourselves a ZIO microservice. So ZIO HTTP microservice, and we will make that a case class for now inside of this folder. There are a few ways of doing this top level sort of server, but I think we have sort of settled on, or at least maybe it's 50-50 either way, but one way you can do it is to just continue to use the service pattern and even make sort of the entry point of your application into a service, which makes it, uniform throughout sort of this fractal service pattern. The top of your application is not an exception, does not have to be an exception. It can follow the same patterns. So we're going to make a case class here. Now I could make a trait. I could make this to be like a microservice trait and then have this be live, extending that trait. But another sort of thing that's sometimes going to be useful is if you do not want to have a test version, if you don't see yourself having a variant of a test implementation, then you don't really need to even do the trait. You can just have a single live implementation, if you will. So we're going to sort of be doing that here. And let me import some stuff. So I think zhttp.http._ and zhttp.service._. Great. And then here, let's say let's just say def start or something. And here we're going to say server.start. I'm just going to give it a port, and then an app thing, which we have not defined yet, which will go right up here. So this is basically the equivalent of our routes. So, oh yes, and Adam has made a live layer there. Let me import all of ZIO as well, because we'll probably want that. So for now it has any, but we're eventually going to add some dependencies to this that we're going to use, but that'll become clear in a minute. But we can at least get started just like this. And okay, you're just doing succeed. Awesome. Okay, so let's make ourselves an app, which is kind of the equivalent of routes. So I'm going to say http.collect ZIO, and then give it request in here. And this will allow us to use pattern matching on some kind of incoming request. And so the way this works is, yes, as I'm getting some hints here, it's going to start with method.get, and then you're going to have an arrow. And then we're going to basically do the path here, starting with this like little double bang for the root route. So we wanted something like this, if we'll recall. Oops. Let me actually pull in my comment that I made in the other file so we can just get an idea of what needs to go in here. So this is the get request. And then we also want the post request. So we're going to be parsing the IP address off of the route. So that's going to just get whatever that is as a string, and we can use it internally. And then what do we do with it? Well, in the Akka HTTP DSL, you sort of have to, it's a little different where you specify what the method is and whatnot, and how you're parsing these segments out, these path segments. But here is basically the equivalent of the callback. Let's just pull this over so we can get an idea of what that should look like. So basically, we want to call to some fetch IP info method. And so this is where maybe instead of just sort of importing this at the top of our application, everything is kind of done in one file, and this is dependencies on an actor system and on config. This is this big trait thing, which is then being instantiated later with an actor system and an executor. So it's this kind of cake pattern, which personally, I mean, it works fine in this very small example, but personally, I find the cake pattern very difficult to navigate with code bases because you just get this interwoven tangle of extension, and it becomes difficult to know, like, okay, where's this actor system coming from? Where's this config coming from? Can I just copy paste this function somewhere else? So I think what I want to do is basically take this function signature that we're using, fetch IP info, and turn that into a ZIO service. So that's basically all we're calling ever from our server is this fetch IP info thing. So I'm going to go to, I'm going to make an IP service. I'm just going to plop in this this thing right here. And of course, because this is a ZIO application and we're not using futures, I will instead make this into a task, which is sort of the ZIO equivalent of a future in that it can fail. Basically, if I were to do the full ZIO type alias, it does not have any environmental dependencies, and it can fail with a throwable. Now, there's this either string IP info as well, and perhaps generally you don't really have, it depends, but because ZIO does have typed errors, generally you don't have this sort of either as the success type. Sometimes you might, but we eventually might want ourselves some kind of app error, and we can sort of put whatever this string represents. I'm not even sure what it does represent yet, but we can put it inside of some error type and have this represent sort of our app error. So the ideal final API for this might look something like this, but for now, we're just going to keep it simple and do this incrementally. So we're not going to make too many refactorings all at once. Great. And we also haven't implemented this yet at all. We have no live implementation, but we're not even going to worry about that because all we care about right now is this trait. So it's very much something I like to do is just keep things as stubs, or if it's a trait, you don't even need to make a stub. You can just keep it as a trait. And then here inside of the ZIO HTTP microservice, we're going to add as a dependency that IP service, which will allow us to call IP service.fetch IP info with some IP address. Yay. And now this is going to get us back that either. So let me go here and say info. Cool. Then we can basically match on the info. Let's see what we're doing in the previous implementation. If there's an error message, we are making a bad request response. So let's say that we're trying to come up with a response here. And I don't think we're even going to perform a ZIO effect, so we can just use the equal sign there. And so we have the error message, and then we have the actual info value. So in the case of it being an error, we will say response.text of, I think it was the error message, and then sort of do something like this, except I believe bad request is formatted like that. I think it's set status. There we go. So that we're going to have that failure status message. Otherwise, we are going to use the JSON. Use the JSON and encode that value, encode that info as JSON. Now I am a little confused as okay, why it's compiling. It's not compiling. Good, because they are using sort of that cakey pattern, the cakey pattern. So we don't have any encoders. So what we would need to do is kind of extend this protocols. Sometimes in certain companies or what have you, people do not like to define the encoders or codecs on the types themselves or on the companion objects of the type. I generally prefer that. Hopefully you don't have too many conflicting ways of encoding and decoding the same data type. And if you can get away with it, what would solve this problem as well, so we don't have to make sure that we extend the right protocol everywhere, which also obviously gives the opportunity for us to extend different protocols accidentally, and use different encoders and decoders that do not actually mesh with each other. The way to avoid that, what type is this? It is the info is an IP info. So we can go here, grab this, and put that, in fact, on the IP info companion object, which will make it discoverable by the implicit system. So let's just pull all these in here. And I'll just import everything. Now, eventually, we're going to probably turn this over to using ZIO JSON, but that's a tall order for maybe starting out a migration, and there's no real need to do that at all. Everything will still work with any JSON encoding or decoding library. So I believe that's pretty much the first response that's been translated over. It looks relatively identical to me. So I'll just delete that comment. And then we'll add another one for this. So in this case, method post, bang, bang, IP. Now, with the current DSL, this sort of collect DSL that uses pattern matching, we basically, in order to get a body of a post request, we need to get this whole request. And there's this method on it called request.body. And then we can sort of parse the body as various things, one of which would be a string. So I could say body string here. And in the other version, of course, they're using this entity type that's sort of building this parser and saying entity as this thing, which is basically using eventually at the base this decoder. And it's going to handle the decoding of that body sort of internally, which is, I think, ideal instead of us having to do it manually. And that's something that we're working to add to the technically that already does exist as part of the API DSL we're working on. But we're just doing the collect API today, which is a little lower level, more akin to what you'll do with something like HTTP4S for now. But eventually we're going to get that out there. And I'm sure we'll do another session where we upgrade something like this or a different application to using that API DSL, which will hopefully remove a lot of the boilerplate, if there is any boilerplate here, if you consider this to be boilerplate. And I think I would consider what we're about to do sort of boilerplatey. But we need to get Akka out of our code base so we don't spend $1 billion this quarter or whatever. Okay. But basically, once we get that, we're just calling both of these as futures and then zipping them together. And if we know about futures, we know that they are eagerly evaluated. So the second that we call these methods, it's going to kick off those processes on new threads. And so we're sort of using, we're sort of running these in parallel, even though there is no real distinction in the future world. There is no method called zip par versus zip. It sort of just depends on when you've defined the futures, at what point you've defined the futures. And in this case, with this pattern, it's going to run them in parallel, but we'll see that we're going to run them in parallel using a different approach in a moment. And then basically, if both of those succeeded, we're going to get back a summary. Otherwise, we're going to fail, starting with the left error message or then the right side's error message. And we could probably fix that up a little bit if we translate this from being returning an either everywhere to returning a failure. We could basically consolidate our error handling at the top of our application, and maybe that's a good thing to just note, because I see that pattern is being repeated here a lot. Cool. And that would be a good show of the error channel. So let's see. For now, let's just do this manually. So we could say request, no, we have the body string, and then we're going to say, I think, as JSON. And then we're going to say as, what was it? Request, IP, yes, IP pair summary request. I got to import that type. Great. And we don't want to do anything with that yet. But I do want to say ZIO.from either, because that's going to return an either. And we'll just lift that up, that failure up into the error channel, I believe. What's sad? Oh, and of course, once again, we do not have the decoder for that. So that's another reason to move that stuff from here to the model itself, so that that'll show up everywhere. So I'm going to make this larger. Companion objects. Oh, sorry, just the there's a little.
You have your tricks with IntelliJ.
Exactly, that's why I'm an addict. And then what is it? Derived, generic, semi-auto. It's kind of auto. Great, and so hopefully that's enough now to remove that warning there. Perfect. So now we have the request, or the summary, whatever request, I guess. Cool. And now what we did in the previous implementation, if I could copy it over for reference, would be basically to call that twice and zipping them together. So if we just did something like, what was it? IP service dot fetch IP info for one side, for the, what was it? Summary request IP1. We could get the info 1, and then we could do this again with info 2. And that would be all fine, except it would do this sequentially, right? In a for comprehension, these lines have to complete before it will move on to the next line, which makes sense because we sort of have the result of the previous line in scope. So it would have to have been completed to get its result in scope to potentially determine subsequent calculations using the results of the preceding ones. But there are a couple ways around this. First of all, we can call fork if we wanted to, but that's a bit manual. What we probably just want to do is use an operator like a zip, which is kind of what they're doing in their future example. And if I do zip, we're going to get the results. But if I do zip par, it will, oh, Adam, you got it?
Yep.
Do it, yeah. Now it's going to run those in parallel. So we have sort of, we can use the operator to determine the parallelism instead of sort of the trickier notion of where you've defined your ZIO, your future, because futures are not referentially transparent. So if I were to inline these definitions using some other tricks of the trade of IntelliJ, now this would be sequential versus extracting it, it would become parallelized, which is a tricky thing to have to remember and to deal with, especially if maybe those were truly dependent on one another and they needed to be sequential. Then extracting or refactoring could in fact break some code. But here we have to sort of, decide this it's not going to change if we pull this out into a different definition. Cool. So I'll just do that. So we have these two results, and then let's I think match on them is kind of what they were doing. So let's get the response. Maybe we can clean this up later, but for now we'll just keep it kind of similar. So if we have writes of info 1 and info 2, we're going to create this IP pair summary. Was that what it was called? IP pair, yes. Does not seem to find it. There it goes. Which, as we know now, is actually the secret apply method that's going to also calculate the distances between them. So that's not so fun. Maybe I will rename this. Oh, is that going to work? Oh no, something horrible is happening. Can I rename this? Rename containing objects. no, I don't want to rename. I think it's tricky to rename the apply method. So let's just forget about that. Potential refactoring. Great. So if they both are good, no problem. We're going to make a JSON response where we JSONify their summary that contains the distance between these. Otherwise, we're going to sort of get the first error from each of them and just return that as a bad request. And ideally, we can make that cleaner, and then we'll just return the response. But that's basically it for the server itself. So I sort of like this pattern a lot because it's that sort of fractal Z layer pattern where we've just defined our functionality. And if we have dependencies on other services or other entities, we just list those as constructor arguments. And eventually we're going to create a layer out of those.
Yeah.
So one other way of doing, oh, so you did from function, awesome. Just to show off something else that's a little silly, but I have a little snippet that'll basically just do that as well, based on the name of the containing object, which ends up being pretty fancy, and a little bit of a time saver. And then we can just add that type. I should share that online, but this is totally great as well. Oh, did you say something, Adam? I think I heard like a chop.
No, I was just saying that was very fancy.
Very fancy. So great. So we have to basically at some other point define an IP service, which we have done up here. But now we need, I think we're probably at the stage where we need to actually make an implementation. Though first, let's try to like have sort of our main. Let's make ourselves a ZIO main, I'll call it, because I'm not sure if there's another main somewhere. And here I'm going to extend ZIO app default, which basically just needs a run method. And so this is going to be the true top of our application, which sometimes in the past I've sort of made the ZIO HTTP microservice be the like the server definition itself occur at the top level of the application. But I found because that's not always trivial, and sometimes you need dependencies in other services or whatnot, to sort of use that fractal service pattern really for everything up until the very top, where basically you're just going to call and delegate to some single method like start, for instance, on some other service. So to do that, what I can do here is just say ZIO.service with ZIO, and I can grab myself a ZIO HTTP microservice and then just call start on it. And if I were to try to build this, we should see an error.
Fancy error.
Which is saying that your effect requires a service that is not in the environment. Please provide a layer for the following type ZIO HTTP microservice. And now we can sort of use provide and all of its nice macro assistance to help guide us for what we need to do. So first we need a microservice, and we need to start just providing layers. So obviously that's .live. And I'll build again. And now we need an IP microservice. So I could say IP service dot
IP service live dot layer. Just change it up slightly.
IP service live dot layer. Gotcha. And there we go.
Oh.
And I'm guessing that has some stubs. And okay, it's just a stub for now, but nice. So now the question would be, let's actually implement that. So we sort of have worked from the top down. Though we said we sort of didn't really want to have to re-implement everything. So let's see if we can reuse as much of this logic as possible. So I'm just going to go here and grab all of this and not even worry about the other implicit dependencies that it has for now. And we'll just go into here and basically paste in that stuff. And of course, we get a whole bunch of things we need to import. And maybe to simplify this, I'll just go into this main application and just copy paste everything, and then just have IntelliJ clean up what we don't need. So I'll pull in too much. And then after it can figure out what's actually being used, I will click optimize imports, and hopefully it can remove a few of those. So there we go. Cool. All right. And here we can see some things that are maybe blowing up for various reasons. And if I hover, I'll see that I think one of the things that we need is a, let me see this, we need an actor system. So let's just add it up here. Yes, exactly. So instead of trying to figure out how to really just like, where do these come from, whatever, if it's something that we don't know about that we need, let's just add it as a parameter. It's a dependency. Implicit val system. It needs to be implicit, unfortunately. We don't love implicits in ZIO, but these other systems and styles do require them. We also need a, I think, an executor or some kind of dispatcher, but we can grab that out of the system. It's a dispatcher. Actor system.dispatcher. Yeah, an executor is what we need. Executor. So we can make that implicit as well. Executor. So a couple private implicits. And then of course, it's grabbing this config, which I believe is, if I go to this other file, it's a type safe config, which is actually ironic because it's not actually type safe at all. We're clearly just getting, I guess it's kind of type safe, but we're accessing it. It's at least not compile time type safe, not to my standards of type safety. Maybe back in the day, this was better than just strings, but obviously there's no guarantee that at this point services.ip.api.host exists in your config, or that's a string or an int or whatever. Ideally, we calculate this all ahead of time, and there are multiple ways we could do this. But in the interest of making it incremental, let's just do that thing. Let's just do that config thing that they have. And so it'll still compile. And we can note that maybe we can eventually make ourselves a different trait that's a sort of an IP service config. That's just a case class with that information in it. And we can parse it out at the beginning of the world, where we'll get a nice error message instead of potentially once our application is already started. But for now, that's going to be fine. And then there's this logging. And we're gonna change some stuff around here because this is using futures. So we're not going to worry about the logger. And what does this need? This needs also, yes, unmarshalling needs itself that final encoder decoder. So I'll copy this, go to IP pair summary, and oh, do we already have one? Oh, no, there's no codec. Oh, there is one. There was already one there. So that's interesting. So there was actually already a danger of this pattern where they had now two implicits for that type. So let me delete the protocols at this point because I've defined everything. I'm not sure if ambiguous implicits is the cause for that. It might be. I don't think so, though. This is sad because it could not find an unmarshaller. All right, I'm not quite sure where it got its unmarshaller from. That is not a data type I'm familiar with, but let's figure it out. How would you even figure out what that needs? This needs an unmarshaller. Great. It needs it right there. I would think it's going to be one of these encoders or decoders, but apparently it's something else. Oh, and in fact, wait a second. Oh, it's failing here now. So maybe there was something else in protocol that I destroyed. Oh, error accumulating Circe support. Maybe that's needed. I don't really know if that is needed. Let me extend in this with protocols. I don't love to do that, but if it requires that weird accumulating thing, let's see if that is in fact the problem. Okay, that seems to fix it. I don't know if that is the problem or not, but
we're down to a different problem that's, I think, much more solvable.
Yep. I'm just going to delete everything except for that. Yeah, so it looks like we need this accumulating Circe support, which probably, I'm guessing, oh yeah, error accumulating unmarshaller. So that is necessary, I guess, for the whatever kind of, yeah, whatever it's doing here with unmarshal, we need that implicit added.
We can open a ticket for that.
Yeah, not my favorite, but we'll just, yeah, some APIs force you to use that kind of trade pattern. Not my favorite, but let me just delete this protocol, which now just was for that, and just put that in there directly, which is longer, but we'll at least remove something that's just kind of misdirection. And hopefully everything is still happy. Protocols is not a member. No, it is not. It is dead. Protocols is dead.
Long live protocols.
Long live the error accumulating Circe support. Okay, so now we've gotten to the fact that there is no logger, and we could add logger, but at this point, I think it's relatively easy to support that with ZIO itself, even though, let's see if we can do that just yet, because they're still using a bunch of future stuff.
So we could do it and we could unsafely run it. I mean, it's not a bad way to just demonstrate that if we wanted to.
That is true. I guess one thing, there are a couple ways we could go about this, right? So one would be to wrap, like we could transform something, or we could we can move it from future to ZIO entirely from the base level, or we could just wrap it. So I think maybe for this one we can keep as a future, because it's doing the source single via thing, and we are going to have to basically replace this with HTTP, which might be a bit more work. So for now, let's just wrap this, and I'll just say ZIO.from future, which is nice to have, which takes an execution context, a function from an execution context if we wanted to use the ZIO one, but here we'll use the actor system or what have you. And yeah, we're going to get back a task of HTTP response. So now we can still call flat map here, except that and now it's going to basically be returning a future here, but we don't want to return a future. ooh, and it looks like this unmarshaller itself returns a future, which is definitely weird to me, that just some JSON decoder would return a future, but I'm guessing it's just to be done to fit into everything else. So we'll just wrap that as well. Future successful, that's easy. I could just do ZIO.succeed. So that's an easy thing to translate. And then let's see what else we need. And now that we're in here, this is also going to be a future. So I'll say ZIO.from future. Do that unmarshaller thing that inexplicably returns a future. And then, yeah. And then it looks like Adam's fixing up the error to use ZIO.log error. And then ZIO.fail. Instead of future.fail. So that I think is, yeah, there's some awkwardness at the boundaries, but ideally we can sort of work that boundary along and clean it up as we go. But of course there's a bit of a wrinkle. Yep.
One watch out here is I had to add this zip right on line 52. So make sure that sometimes if you're going from something where you have two statements that are side affecting and you're converting those to ZIO workflows, because these ZIO workflows are just descriptions, you've got to actually compose them together. So that's where this zip right operator comes in.
Yeah, and if you just did that, this would luckily in IntelliJ become grayed out to hint that sort of, well, you're not using the results of this pure computation, which is just giving you a ZIO blueprint to log. It's not actually logging. So you're going to need to build a bigger blueprint that first logs and then fails. Though one would think that if one is failing, this error should actually be reported somewhere else. That's something I've noticed in a lot of sort of larger applications that didn't use ZIO, is that because errors are a little difficult to track sometimes, there is a lot of superfluous logging. It seems to be a fun thing to do. But theoretically, we should at some higher level log all those errors. So I would actually say like maybe we don't need to log at all at the end, but for now we could just keep it as an example, as a direct translation. But ideally, whatever is running this would log all thrown exceptions. Great. And that was a fail, but do you know what that was before? Let me just check the other.
Originally it was future.
Okay. Okay, future.failed, which is also why I was reticent to translate this just to be like an IO of throwable IP info, because they are sort of using that whole ternary possibility state of it throwing an exception, which is the throwable, or it failing with a string, or it's succeeding correctly. So in ZIO, that's why we have that error channel. So we have the error channel would be, I guess in this case, that string, that we should give it a better name. We would have IP info being the success. And then if we really had something truly catastrophic that they're not trying to handle really until the end of their application, that's where we could potentially die or something, because we just do not care. This is totally wrong. Though maybe we would in fact want to turn this into a left as well, because I don't know. I don't see why the incorrect IP format is so much different than, I guess, the request failing to parse, but maybe that is more catastrophic and there's really no handling. So, but yeah, we generally don't need to have a ZIO of a throwable error and then an either as the result type, because we kind of are given that by just having more error expressivity in ZIO, by having that error channel, which just future does not have. It just has throwable by default. Okay, and if we want to remove the any, we could. Great. So I think that's that, and we're just going to keep all this, even if we don't really fully understand it. If not, I personally don't fully understand exactly how that's working internally, but whatever. Or I guess I kind of do it at a high level, but nonetheless, yeah, I don't even know where they're getting the actor system from yet. We've sort of kicked that can down the road. So now our layer requires config and actor service, an actor system. So we'll need to give it a config and an actor system before we can run this. And the oops, HTTP looks like it's been confused, probably because of that HTTP. Do I need that HTTP? I do, I need that one. So let me, we have some conflicts here. Let me alias one of these. So I'll make HTTP into Akka HTTP and replace that there. Oh, and is that unhappy? Why would that be unhappy? Oh, because I've done something horrible? I don't really see what I've done horrible, but we'll see. Identifier expected, but oops, with. I probably undid something. Good, and now we need, of course, an actor system and a type safe config at the top of our world. And if we go to sort of how they're constructing these, well, they're just building a config and an actor system. And so instead of doing this whole machinery, I could just make, I guess, yeah, oh, there you go. Oh, nice. And you've even, oh, you're way ahead of
Did
me.
something real for the actor system layer, which is kind of a nice thing with ZIO of like the actor system. You look at all these examples they just like created, they never like shut it down, which technically you're supposed to shut it down. And ZIO makes it really easy to like, we have this layer that encompasses all this logic for us. So it's going to create the actor system when we construct the layer, and it's going to provide it to us. And it's going to guarantee that as soon as we get done, we're going to shut down the actor system.
Nice. And I love my aliases, so I'll replace those because these are just, yeah, I guess technically they could blow up, but if they do, we just want to see that error right away. We don't want to recover from it, hence the die channel. You know, this is going to happen at the beginning of the application. And I think something was changed there. Oops, let me undo that. So config factory.load, perfect. So that's a little simpler. I don't think we need to shut down our config. Oh, what happened
Oops, there? I think we shared something.
I don't think you need the ZIO though. You could just do, right? You could just do, can you just do zlayer.succeed?
Oh yeah, we can do that.
Cool. Sweet. Nice. So that's that. Now we have an actor system and a config layer. And if I rebuild, that's now being passed along there. And there are no protocols. No, I deleted them. They're dead. They're dead. Oh, but now this probably means also this is why I hate these traits. Okay, sorry for being not zoomed in. Great. Okay, so now everything seems to be at least compiling. I mean, that's pretty much a first pass, and I guess it has been an hour. Are there any? Well, yeah. Let me just summarize real quick and clean up those imports. So, ideally, yeah, this IP service would now be in its own nice little file. Let me do that using my little move command that I love so much, and hopefully it does all the imports. It did, except for ZLayer. So let me import ZLayer and try to build one more time. And it forgot about the Akka HTTP alias. So let me grab. Oh, it's been removed, so that's fun. Import akka.http.scala.dsl. Oh, there we go. Akka HTTP. Okay, now it should be happy. IntelliJ commands sometimes drop imports, unfortunately, but mostly pretty damn swell. I certainly couldn't live without it, even with its weirdness. Cool. So now we have one file, which is just the IP service, and for some reason it moves the trait at the bottom. Where did it move the trait? Where'd the trait go? I didn't move the trait at all. Let me grab that trait and put it, I guess, in here. It could be in another file, but for now, I'll just put it in here. Great. So we have the IP service trait, which defines really all we cared about the IP service. And it was a little difficult to tell in the old version where all these methods and flows were all just sort of co-located at the top of the application. But by reducing that, all the thing that we care about on the outside world to this trait, we can forget about all the implementation details and let them live inside of the implementation of the live service, because that their only concerns, only the live implementation is concerned with this. We could have other implementations for testing that didn't actually hit this API, which would actually be really good. This is a case where you want to model this service as a trait, because when we test this, we probably don't actually wish to hit this host. I'm guessing in their specs, they're mocking some HTTP endpoint, and it looks like they are making like a fake flow and all that, which is cool and all, but really, if you trust the fact that it's hitting an API correctly, everything else can just sort of work against a fake IP service instead of like having to mock out like HTTP requests when all you could do is mock out the simpler data type, which is an IP info, and test against that. Maybe we can get to that in the future. But yeah, so now we have the ZIO HTTP microservice that just defines this collect style ZIO HTTP application. That's a pretty direct mapping. And as we mentioned, we probably in the future wish to oh, I already named requests. Anything. Let me just do summary. Want that to be shorter. Okay. And in the future, we're going to probably take a look at migrating this once again to the API DSL that we're working on, because we think that'll be even cleaner and shorter and easier to work with, and give us hopefully, Swagger docs and all that good stuff. But yeah, hopefully this was sort of a nice recap of the service pattern and how it can make things simple and how you might approach at a high level working your way through this application, especially like the fact that this IP service we kept all the same logic. We just kind of layerified it, and didn't have to remove the actor system. It's just now this this dependency on this service. But you can imagine over time, as you serviceify things, we could re-implement this Akka service into using something else. Basically make a non-Akka implementation of this. So this could be IP service Akka, IP service Akka. And then like a Jira ticket in your system could be like rewrite that to use HTTP or something, or ZIO HTTP or whatever. And then you can delete slowly everything in your service in your layers that depends on the actor system. And of course, we could say zlayer.debug. Let's go with the full mermaid experience to see basically what is being depended upon. Let me go to the build outputs. There it is. And then we click on that beautiful link and see, hopefully, everything works, that, there's our actor system. It's being used by the IP service Akka. Not so surprising. So one might imagine a huge graph here, and hopefully over time, you can sort of snip these connections to the actor system until you can finally, delete Akka and give it a nice Viking burial. Light your code base on fire and kick it off into the ocean. Woo! Any questions? Why is your brightness level changing? Was it changing? Hopefully it wasn't, but it could have been, once again, just me. If I was hitting my brightness thing, me being crazy.
I didn't notice personally, but I also may not have noticed.
Yes, I was. Yeah, I get so excited at points that it charges my computer. So these flows are actually quite useful. Low latency, and you control rate centrally on this resource. Oh, well, interesting. That's a good point. There might be some reasons to have the flow, though I would think that there probably are other ways of dealing with that. For instance, I mean, if you are, generally, as I think HTTP would, I'm not quite sure about the internals, but when you make a request, HTTP is actually its own service. The backend is its own service. And that buffering, that back pressuring could be handled as an implementation detail. Because really what they are doing is the API that they're exposing here is to submit a single request to that flow. So I think you could reconstitute the same capabilities in a slightly more ergonomic way and hide the implementation details of there being, yes, a queue under the hood somewhere, though I guess they're not even really using that here. Sorry, Adam.
No, I think you answered perfectly.
Pure config, or rather ZIO config plus Magnolia makes it type safe. Yeah, I think just because we're sort of coming to the 3 o'clock or we're past the 3 o'clock, we should probably do a follow-up where we continue to port that. But yeah, and hopefully we can get our DSL done across the finish line soon. But yeah, if there's anything else you'd like to see about porting an application, let us know. But yeah, definitely doing config in a semi-real world application would be great. And this is kind of semi-real world. I like this. If anyone has any other applications that they could find on GitHub that they've either written themselves or they just see out there as a good example, let us know, and maybe we could try to show how we would ZIOify it, or otherwise, pepper it with our opinionated criticisms, potentially unfairly. But either way, that was fun. Can't see the actual level. Okay, that probably was me then. I don't know. I'm switching between tabs are slightly different. Oh yeah, because maybe this screen was so bright that I dimmed it and then I read. Yeah, that might be me. Oh yeah, because I don't think they would stream the actual brightness level. So I'm adjusting the brightness of my screen to cater to my very delicate retina. Okay, well, that was fun. And see you all next Friday. I think we might be doing it slightly earlier and or later. So keep an eye out. We'll on that. But yeah.
Thanks so much, everyone.
Thanks, everybody.
Bye.
Bye.